Hello ladies and gents. In this video we're going to take a look at a couple of functions in Excel used with the binomial distribution, specifically the Binom.DIST function and the Binom.DIST.RANGE function. Over here on this spreadsheet what I've got is the coin flipping experiment which we've been talking about in class. Here, I'm just going to make this a little bit bigger here so you can see it a little bit better. Okay, so what we've got here is that we've got 10 coins that we are flipping, and the success is going to be considered to be a head. So in this case then, we've got n is equal to 10 trials, p is equal to 0.5, and that's the probability of getting a head per coin or per flip, per trial. X takes on the values of 0 to 10, and they represent the number of successes in n trials. So in this case then would be the number of heads that we get in 10 flips. Now the important thing to remember about X is that it starts at 0, because you can have no successes. It doesn't go 1 to 10, it actually goes 0 to 10. So what I'm going to do down here is use Excel to make a probability distribution. So I've got the values of X here, and then beside them under the P of X column, I want to put in the actual probability. What's the probability that if I toss 10 coins, that all of them turn out to be tails? That is, none of them, 0 of them, are heads. So the function that we use here is something called the Binom.DIST function. Let's go and find it here. I'm going to go up to Formulas, More Functions, Statistical. And if you take a look here, you'll see that there's actually 3 different functions for a binomial distribution. We'll be looking at the Binom.DIST function, the Binom.DIST.RANGE function. We won't look at the Binom.INVERSE function, although we will look at its equivalent when we get into Unit N on the normal distribution. So let's start with this guy right here, which is the Binom.DIST function. That's the main one that you'll be using. Click on that, and it'll bring up a little dialog box. I'm using a Mac, and so it shows it as the formula builder to the right. But if you are using a PC, then you'll see the same boxes here. So the first argument or part of the function is something called the number of successes. And so in this particular case then, we're saying that that's 0. And so I could type in a 0. It's probably a little easier for me though to go and just simply click on the cell, in this case A12, that has the 0 in it. Because what we're going to do is we're going to copy this function all the way down the column here. So that's the first part or argument of the function, is the value of X, in this case, is 0 successes. Let's go back over here, and we're going to click in the box that says trials. And the number of trials then is 10. So we've got 10 coins that we are tossing. So we can type in 10. Now, just as an aside, I know in Excel it's more efficient to put that 10 into a separate box and then reference it. So click on the cell that has the 10 in it and use it. For the assignments that we'll be doing, I'd like you not to do that. I'd like you to actually type it in as a constant. Now that is less efficient from an Excel point of view, but it sure is a lot easier when it comes to marking, because I'll see the exact number that you used here rather than just a cell reference like C4 or something like that. Okay, so type in the number 10. Similarly then, for the probability of success, that's your P. So we would type in here 0.5, or you could type it in as a fraction 1/2. The last argument here is it says cumulative, and it says that it's a logical function. So you either type in here false or you type in true. Now false is used when you want to know what is the probability that X is exactly equal to something. So in this case, the probability that x is exactly equal to 0. If you type in true, it talks about what's the probability of that x is some number down. So if I put in, for instance, say 5 as my x value, and then I put in true as the last argument, it would actually give me the probability from x all the way down from 5, 5, 4, 3, 2, 1, 0, that whole cumulative probability. So in our case then, in just simply building a probability table, I'm going to type in here that this is false, because I want to know the probability that x is exactly equal to 0, not less than or equal to 0. So those are the parts. I'm going to press done. And what I get here is 0.0010. Of course, I can change the number of decimal places, increase, decrease that. I've actually already done that before as I was doing a trial here. And so I've got it as 4 decimal places because that's what it's going to show up on your table as. So I wanted to get the exact numbers on the table. All right, the last thing that I'm going to do here, I've got the BINOM.DIST function here, but I want to copy that formula and paste it beside it so that you can see the actual arguments of it, or how the thing looks. So I'm going to go up to the top here where I've got the formula bar, and I'm going to just highlight the whole function. I'm going to copy it, push escape to get out of the cell. I'm going to move over and I'm going to paste it. And then I'm going to go to the formula bar up at the top here and put a little equal sign in front of, put a little apostrophe in front of the equal. And that actually makes it into text. So this is what I've got. If you take a look now at that function, you'll see the different parts or arguments of the function, and there's 4 of them. So again, we've got equals binom.dist, and then in brackets you have the different arguments. So the first one, A12, is the reference to the x value, in this case 0. Then the next one, we have comma 10, and the 10 is your n trials, 10 coins. Then we've got 0.5, which is your p. That's the probability of a head. And then the last argument is false, which means that we want the probability that x is exactly equal to 0. All right, now what we can do is we can just simply copy this particular formula all the way down. I'm just going to go to the corner here, and it changes into a different kind of plus sign, and just double click, and it copies all the way down. If you take a look at the formula bar up here, you'll notice that everything will stay the same except for the first argument. The A12 will change to a 13, to a 14, to a 15, and so on like that. And so in each case then what it's doing is referencing the cell to the left, which is in this case the 8 as the first argument, but the rest stay the same. Now that gives us a probability distribution, and if we were to take a look at the properties of probability distribution, remember that all the probabilities are between 0 and 1, and that in terms of the probability distribution, these are mutually exclusive, means that if you flip a coin, if you flip 10 coins, then if you got 3 heads, it means you didn't in the same experiment get 7 heads, right? One precludes the others. And the last thing is that they're collectively exhaustive. If I was to sum this up, this column up, this should come to 100%. There you go. So that's all the possibilities. So it exhausts all the possibilities, and collectively they add up to 100%. All right, now over on the right hand side here, I've got the histogram here. And so it I did a little bit of work beforehand and it automatically built. One thing I want you to note, though, about a binomial distribution is that there's actually no thickness to the bars. They're actually just vertical lines. And so it looks like that there's some thickness to each bar. There isn't. It's just 0, 1, 2, 3, 4, and there's nothing in between. So that's really important for you to note that that's an artificial thickness there, and just to show that there is a bar. That's what Excel does there. But it would probably be better just to show them as lines. Okay, let's calculate some probabilities down here. And so I'm going to make this just a little bit smaller. And I've got some probabilities that we're going to look at down here at the bottom here. So the first one is the probability that x is less than or equal to 3. I don't know if you can see that whole thing. You know what I'll do is, oops, I'm going to see if I can grab this whole thing and just move it down here. And maybe we'll move down and then we'll make it a little bigger again, just so you can see it better. All right, that's probably a little better like that. So let's take a look at the probability that x is less than or equal to 3. Now, if I was to take a look at my probability distribution, that would be the sum of these guys here. So that's about, what, 12%, and another 4, 16. So somewhere around 16 to 17%. Yeah, so that's what the answer should end up being. Fortunately, I don't need to use a sum function here on a built distribution. I can actually use this by using the BINOM.DIST function. So let's go and build that. And so I'm going to go into formulas at the top here, more functions, statistical, BINOM.DIST, and then again my formula builder comes to the right here, and the number that I'm going to put in here then is 3, because we're looking at the probability that x is less than or equal to 3. So I just type in a 3. The number of trials, of course, is 10. The probability is 0.5. As I mentioned, I could type this in as a fraction, 1 divided by 2. That actually works as well. And here's where we're going to make a difference from what we did before. For cumulative, we're going to say true. So when you're looking at an inequality, you're always going to be using true. So that's going to give you the probability of 3, 2, 1, 0, all added up. It should be something around 15 to 16%. Oh, 17%. I guess I wasn't very good at adding that. All right. I'm just going to copy that so that you can see that function. And I'm going to put the little apostrophe here. So that's what the thing looks like. Again, I used 1//2 instead of 0.5. It doesn't matter. You can use either one. All right, let's take a look now at the probability that x is greater than 4. Now let's take a look at let's take a look over here at the chart. And when it says greater than 4, it means it actually doesn't include 4. It's starting at 5. Right? Greater than 4 doesn't include 4. It means it actually starts with 5. That's important to remember with a discrete distribution, which is what binomial is, where you can't have anything in between. They jump 0, 1, 2, 3, 4, 5, and so on, all the way up as integers. So you can't have 4.5 successes. So what we want to do is to first recognize that we're really looking at the probability that x is greater than or equal to 5. So you always want to change it to something that has greater than or equal to in it. Now, the other thing to note then is that the BINOM.DIST function is always giving the area from some point down. And so let's take a look at what we've got here. If we're looking at greater than 4, it's talking about summing up these bars, 5, 6, 7, 8, 9, 10. But the binom.dist function always gives you the area from some point down. So the question is, what's left over from 5, 6, 7, 8, 9, 10? What's left over is 4, 3, 2, 1, 0. Let me show you over here. If we're talking about greater than 4, then we're talking about 5 and up. So I'm just going to color that. But the binom.dist function gives you the probability from some point down. So what's left over? 4 down. I'll put that in a different color. Now together, these two make up 100%. So this is how you do this. You go equals 1 minus, and then you go and grab your binom.dist function. So formulas, statistical, binom.dist, and the number that I put in here is 4. I want 5 up, so what's left over is 4 down. So I've got 4, number of trials is 10, probability is 0.5, and cumulative is true. And so what we end up with is 62%, and I'm just going to put a little apostrophe there so you can see that formula. The other thing I should do is probably change these so that they're a couple of decimal places only, my final answer here. Something like that. Okay. I kept these ones as 4 because that's how they're shown on the table, and we'll be taking a look at the table in class. But the final answers here can be to 2 decimal places. All right, let's take a look at this one here, the probability that x is between 2 and 7. Actually, it's greater than or equal to 2, but less than 7. So let's go over here to our graph here. And that's showing 2, 3, 4, 5, and 6. It wouldn't actually include 7, would it? Because it's less than 7. So it's 2 to 6. Let me go up here, and I'll color those differently. Those would be these guys here. Color them maybe like that. So I'd be looking at the green cells there. So the first thing I want you to note then is that this is equivalent to the probability that, well, let's just do it this way. I'm just going to change this part here to less than or equal to 6, like that. So I'm changing all of my greater than or less than signs to have equalities in them, greater than or equal to or less than or equal to. So that's between then and including 2 to 6, 2, 3, 4, 5, and 6. There's 2 ways that I can do this. One is to use the 2 binom.dist functions. By the way, up to now what I've done is gone up to the very top where it says formulas and then chosen the binom.dist formula builder. I can actually just type it in. So binom.dist, left bracket, and then it prompts you for the different parts here. So what I would do is I would say the bigger number, which is 6, that's my x value, the number of trials, comma, 10, comma, 0.5, comma, true, minus a binom.dist, left bracket, 2, comma, 10, comma, 0.5, comma, true, close brackets. So that's one way that you can do it, is the bigger number, 6, all the way down to the smaller number, 2, using 2 binom.dist functions in one formula. And that's what I end up with is that. And so let me just copy that. Actually, I'm just going to copy this over. I'm using constants, so the cell references won't change or anything. So that's what it looks like. The second way to use it is to use a function called the Binom.DIST.RANGE. And it's set up a little bit different. In fact, let's go and find it using the formula builder up here. So more functions, statistical, Binom.DIST.RANGE. And it's set up a little different in terms of the order here. So I don't know why they do that, but it has the trials. So that's your n. So you type in 10. Your probability of success, which is 0.5 or 1/2 or just 0.5. And then your two numbers here. So the first number, which is I think you put in the lower number first, and then you put in the higher number, which is 6. So we've got between 2 and 6, and that's what we get. Now, why did that not work? Okay, that's actually the right answer. You know why? Let's go back up here, because this is actually wrong. Does anybody see what the problem is? Well, here's the thing, is the first part is Binom.DIST using a 6, so that would be from 6 down. 6, 5, 4, 3, 2, 1, 0. And then I subtracted off from 2 down. 2, 1, 0. But that would actually leave me with 3, 4, 5, 6. I want to be left with 2, 3, 4, 5, 6. You see the difference there? So I should have actually been subtracting off a 1 here. So I'm just going to go and change that 2 to a 1. And I should get the same answer here. I'll do it here as well in the text. So again, take a look. If you're using two Binom.DIST functions, it's going to be 6 down minus 1 down, and that will leave you with 2, 3, 4, 5, 6. Now, the Binom.DIST range function does that for you without having to scratch your head about, well, where does it start and stop and all that kind of stuff. So here's the Binom.DIST range function, like that. Last thing is I'm just going to take these down to a couple of decimal places, which is like that. And there we go. So those are the functions that you use with a binomial distribution. And that is where we're going to end the lesson today.